Assalamu alaikum students, my name is Abdul Hanan and you are watching Study Wali class. Friends, in this lecture we are studying the remaining concentration units which we have studied in our previous lecture. So first of all, please make sure to like, share and comment on my videos, and also subscribe to my channel Study Wali class and press the bell icon for the future notifications. First unit in this lecture is the mole fraction. So first of all, the formula of the mole fraction is that it is equal to mole of solute divided by mole of solute plus mole of solvent, which is the total amount of mole. Okay, and if you have to calculate the mole percentage, you just have to multiply with 100%. You just have to multiply mole fraction with the 100. That is the mole of solute over mole of solute plus mole of solvent multiplied by 100. Okay, and the important point is that the mole fraction is the temperature independent quantity because the moles are not have any relation with the temperature. Okay, so the next concentration unit is the parts per million, which is the ppm. The formula of the ppm is the solute mass or volume divided by solution or mass or volume multiplied by 10 raised to power 6. Okay, the important point of the parts of per million is that this concentration unit is used for very dilute solutions. So the first point is that the dilute solutions are those solutions in which the solute quantity is very less as compared to solvent relatively. Okay, so that is why we are using parts per million if we have very dilute solutions. Okay, the next point is that the parts per million is also the temperature independent quantity and the unit is the ppm. Okay, are the two remaining concentration units we have studied in this lecture. So the next we are studying the important MCQ. So the first MCQ is that which of the following samples contain the largest number of atoms. We have to check the which option has the largest number of atoms. So the first of all we have to know, we have to know that what is the formula to find the number of atoms. So the first of all we have known that for the number of atoms we have the formula which is the moles multiplied by Avogadro's numbers, and the moles is equal to given mass over molar mass multiplied by Avogadro's number, and the Avogadro's number value is 6.022 into 10 raised to power 23. Okay, options are 1 gram of nitrogen gas and the delta is 1 gram of boron. So the first of all for the nickel, the given mass is 1 and the molar mass is 58.6, which is the mass number of nickel. Okay, so the 1 divided by 58.6 multiplied by Avogadro's number, which is 6.022 into 10 raised to power 23, is equal to, which I have already calculated, which is the 0.027 into 10 raised to power 22 number of atoms. So these are the number of atoms of the nickel. Okay, this is for the nickel. So the next point is for the calcium. The number of atoms is equal to the given mass is also the 1 and the molar mass is 40, which is the mass number of calcium, and the Avogadro's number, which is the value 6.022 into 6.022 into 10 raised to power 23. So by calculating, the answer is 1.505 into 10 raised to power 22 number of atoms of calcium. So these are the number of atoms of calcium. Okay, for the nitrogen gas, the number of atoms is equal to given mass, which is 1, and the molar mass is the 28, which is the mass number of nitrogen gas, because this is the nitrogen 2. The mass number of the nitrogen simple as an atom is 14, but the gaseous state there are two number of nitrogen in its molecule. So that's why we have to just add up the mass number of the individual atoms, which is the 28. So the 1 by 28 multiplied by Avogadro's number, which is equal to 2.15 into 10 raised to power 22, which is the number of atoms of the nitrogen gas. Okay, For the boron, the number of atoms is equal to the given mass 1 and the molar mass is 11, and the molar mass is 11, which is the mass number of boron, and multiplied by Avogadro's number, which is 6.022 into 10 raised to power 23. Answer is by calculating 5.47 into 10 raised to power 22 number of atoms of boron. So from the answers, the largest number of atoms is delta, which is the 1 gram of boron, which is this. The answer is 5.47 into 10 raised to power 22. Okay, total number of electrons in the one telluride ion, which is the tellurium -2, is atomic number of tellurium is 52. We have to just calculate the total number of electrons. So the first of all, the atomic number represent the either the number of protons or the number of electrons. So the first of all, we have known from the atomic number that the number of electron in the tellurium atom is 52. But there is the ion which having the -2 charge. It means that this ion is having the more 2 electrons in its shell. It means we have to just add the 2 in its 52, which is the atomic number. So the answer is the 54. So the number of electrons in a telluride ion is the 54, which is the part A. Okay, so these are the important MCQs which we have studied in this lecture and the sum of the remaining concentration units. So I hope you have understand it well. Please make sure to like, comment and share to my videos. Also subscribe to my channel Study Wali class and press the bell icon for the future notifications. So until the next video, take care of yourselves. Allah Hafiz.